Hello everyone, and today I would like to share a question for integration, which this integral you have to solve by using two techniques of integration. So for the first technique, it will be substitution, and then the second one would be integrate by part, or in short for IBP. Now, this question I found it on the internet, which is very nice, and I would like to share it with all of you. So let me write it down. So we integrate ln of x times with ln ln of x divided by x dx. Okay. So the first step is to determine which one you want to perform your use substitution, which term you want to let you as. So here um I see that ln of x will be a very suitable substitution. It's because that when you differentiate ln of x, the first derivative you will obtain 1 of x, which is suitable for this integral. When I rearrange the terms, it will be we integrate ln x ln ln x with 1 over x dx. So you could see that we could substitute with this term to obtain our du. So let me write down my right side here. So let u is equal to ln of x, and when we differentiate this, you obtain du is equal to 1 over x dx. And you could see that it's similar to our integral on our left hand side, this one and this one, which means we could perform the u substitution very well. Basically, it's a very simple question. So let us try it out. And all of our ln x terms will be replaced with u. So here will be we integrate u ln u du. Right? So now the next step here is we have to use integrate by part, or IBP for short. And by referring to this LPET, I think there are another acronym for it, but basically this is the arrangement of which one you want to let u as. For L presents a logarithm, for P will be polynomial, E exponential, and T will be trigonometry. So L logarithm, which is ln, or in other words log base E, will be our u, and our dv will be u because it comes after the logarithm with u as a polynomial. So basically the general formula for IBP is u dv is equal to uv minus v du. Okay, now all we have to do is just find our v and du, etc. So it will be u is equal to, wait, I realize that it's not suitable to u because it would confuse. So let me change a bit. I want to make this as p. Well, it's the same thing as long as you substitute it correctly. So here will be p. Okay, so now u is equal to ln p. When we differentiate this, du is equal to 1 over p dp. Okay, and then our dv, it will be p dp. V should be p squared over 2. Now you will have p squared over 2 times with ln p minus, we integrate p squared over 2 times with 1 over p dp. And now solve it as usual. P squared over 2 ln p minus integrate p over 2 p. So it should be p squared over 2 ln p minus p squared over 4 plus c. We add the c because this is the indefinite integral. So yeah, that should be it. If you want to simplify this, I mean, you can by factoring out. But before that, we know that p comes from ln of x, so we have to substitute back into our product, our answer here. Sorry. So p, it will be ln of x. So ln x squared over 2 times with ln of x, then minus with ln of x squared over 4 plus c. And then we can end it by factoring out ln of x with 2 as well, the 4. So it will be 4. Now I'll be factoring out 1 over 4. So here will be 1 over 4 ln square parentheses ln. Sorry. 2 ln x minus 1. And yeah, that should be your answer. Let me check before I do anything else. I always check my answers so that I can not confuse anyone who watches this kind of video. So ln x times with ln x, yeah, divided by x. So it will be, yep, that's how it is done. Okay. So let's recap a bit for this question. So firstly, I identify which term should I replace with, and after that I recognize that the third line is integrate by part, IBP for short. So you have to use LePet, which means which one will you be choosing for your u and for your dv, and then just solve the integral as usual, and you obtain the final answer. Okay. So that is all for me. Thank you so much for watching, and I'll see you when I see you.